Today we're going to talk about what function notation is. We're used to seeing equations written in this format, y equals mx plus b, or in slope-intercept form. And so there are times when we would fill out an input-output table and we would have essentially a t-chart where we would have done, here's our x input and here's our y input. And so we're going to do the same thing. We just have a different way of writing it now, because sometimes when we want to use a computer program, a function key is a good way to always show where your input is going to go. And so let me show how that it gets rewritten. Let's say I want to pick a letter. So f of x is now equal to 2x plus 4. And so in this particular case, all that's happening is the y is changing to f of x. And that will happen in the t chart as well, in the input-output table. This now becomes f of x. It just replaces the y completely. So then if I put in a number like 0, we'd put in a 0 here, which means we put in a 0 here, and then we just work out the problem. So we then put in another number, let's say 2, so f of, I would write it like this. F of 2 is equal to 2 times 2 plus 4, so I'd end up with an answer of 8. And we could continue as we fill out our table. Maybe I wanted you to give you 4 examples in the table. So as you substitute in the number that you want to put in for x, you substitute it in both places for the x, and then you just work it out. So 2 times 4 is 8, plus that makes that 12. So we're going to do the same type of thing over here. Maybe I want to be able to tell the difference between the first function and the second function. And so the way to do that would be to just pick another letter. And they usually use f and g as the most common. And so let's say I chose that this one would be g of x. So when I want to fill out my t-chart, I would put an x here, and I would have put g of x. See how I said g of x, because the x is inside the parentheses. So then if I plug in some numbers like I did before, I would just substitute in 0 here and 0 here, and 0 times that would be 0, 2 times that would be, it works the same way as if that had been a y. All I'm doing is placing the g of x in place of that. And so we would end up with all of our same answers in our t-chart. Now, most times we're going to go to that much trouble when we want a whole t-chart. And so let me give an example of sometimes when we would have strictly just ask you to evaluate each function given a value. So again, they are asking for g sub 5. So f of 5. So when we come over here and we substitute then, f of 5 is equal to 5 plus 7, which is equal to 12. Final answer. So it's not supposed to be anything challenging. It's just a different way to write the same things that we have been using. And it has some applications out in the real world where this might be a little bit more easy for a computer to read than having multiple variables. So again, this would be where I would substitute in this case, a -3. So g of 3 is equal to 3 times -3 minus 8. And then we just work out the answer, which gives me -17 as our final answer. And that will work for any of these. So if you want to just practice that a moment, I'm going to pause the video so that you can have a chance to do that, and then you can check your answers in just a moment. So take a moment, get out some scratch paper.